Okay, welcome to this video on the particle model of matter, which is an important topic. We can use this to explain some properties of fluids and solutions. It is a major topic to cover, so it's important to understand. Further topics in chemistry and physics are built upon this theory. There are four main ideas to the particle model of matter. Okay? First, all matter is made up of tiny particles. Second, the particles of matter are always moving. Third, the particles have spaces between them. Fourth, adding heat to matter makes the particles move faster. So, um, here's a point here where I find a lot of students can make mistakes is um, they have this tendency to believe that in a solid there is no movement of the particles. But that is untrue. Okay, that's not true. They are always moving. So in a solid, you have particles that are sort of just vibrating in place. Okay, heating will make the particles move faster. Likewise, removing heat will make the particles move slower. So previously, you learned how to use the particle model of matter to explain phase changes. Okay, to explain phase changes. In other words, what happens to the particles as something goes from a solid to a liquid to a gas and vice versa. Now we are going to use the particle model of matter to explain why substances dissolve. The particle model of matter states that there are spaces between all particles. This means that in a sample of water, which we have right here, here's a beaker of water for us, there are water particles, and there are many water particles. But if you look at this closely, you can also see that there are many empty spaces between the water particles. The same thing can be said of these sugar particles here. Okay, there are many sugar particles, and in between the sugar particles there are empty spaces. Okay? When you take a look at the sugar, you can see the grains of sugar, okay, or the crystals of sugar. However, each individual sugar crystal will contain an enormous number of invisible smaller sugar particles that invisible so we can't see them. When sugar dissolves, so when you're going from this to here, as the sugar dissolves, okay, as the sugar dissolves, oops, the sugar molecules or the sugar particles separate and they start to mix with the water particles, which is happening in this diagram here. Okay? The model here is showing you how the sugar particles dissolve in water particles. As the sugar particles separate from one another, the spaces are filled in. Okay, so as the sugar particles separate, the smaller water particles, as you can see here, denoted by these little, these smaller blue circles, they fit nicely in between the spaces created by the larger sugar particles that are spreading out. Okay? Now, or they're spreading away from each other, I should say. So here's an example, right? We have sugar here, sugar particle there, and a sugar particle there. And in between these spaces, we have some water particles kind of fitting in between there. So the reason why this happens is because there is an attraction between the sugar particles and the water particles. Okay, so they move closer to each other, and this is how dissolving occurs. Now, another really interesting thing that happens, and I'm going to try drawing an exclamation mark because, oops, there's my exclamation mark. Okay, because it's a surprise. Like you would not expect to see this, but And we cannot do a demonstration, but this is what happens. So let's suppose in this beaker of water and sugar here, we have 150 milliliters of water, okay? And we add to it 50 milliliters of sugar. So what would you expect the total volume to be here? You would expect the total volume to be 200 milliliters. That just makes sense because you have 150 milliliters of water plus 50 milliliters of sugar. That gives you a total volume of 200 milliliters. But this is not what we see, okay? Oftentimes, whenever you dissolve a solute in a solvent, the volume that you observe is actually less than what you would expect. It's less than the volumes of the two separate components. So this volume that you would actually see would probably be just a little bit less, not too much less, but a little bit less than 200 milliliters. And that's because we have the smaller water particles kind of finding the nice little space here in between the larger sugar particles, right? So right here and right here, you know, there's some nice space right there that they find themselves in, and this attraction between the particles causes that volume to go down a little bit. So the total volume is often slightly less than the volume of the two separate components. So another important thing we need to understand and study are the factors that affect the rate of dissolving. So the rate of dissolving, okay, all that means is how fast or how easily. I don't like that. Not how easily. Let me erase that. How fast oops. Oh, okay, we're good. How fast a solvent how fast a solute dissolves. Oh boy, this is very hard to print with this thing. Okay, but anyway, it's how fast a solute dissolves. So one thing you can change is the temperature. As the temperature increases, things tend to dissolve quicker. So for example, if you're making macaroni and cheese, you know, and you want to dissolve that that mixture in milk, you tend to do it when things are hot. It just helps to dissolve things faster. Okay, so increasing temperature causes particles to move faster. Heat energy is transferred by the movement of these particles. The solvent particles bump into solute particles. So if things are moving around faster, well, then that just means that particles are if the temperature is increasing, if the temperature is increasing, then particles are moving faster. Well, that means that the interaction that occurs between those particles of the solvent particle and the solute particles, they have more interaction. The size of the pieces of solute is important too. So if you had, let's say, a big chunk of salt or sugar or some sort of solvent, right, versus if you break it up into tiny little bits, right, this is going to dissolve a lot more readily than, let's say, a big chunk. Okay? Small pieces dissolve faster than larger ones. That's just it. So the question then is why? And that's answered in our next point. Smaller pieces have a larger surface area. In other words, the solvent will be exposed to more solute if the solute is in smaller pieces. Okay, so we have that larger surface area. That larger surface area will help things dissolve faster. And of course, in line with temperature, with increasing motion of the particles, which we can also obtain through stirring, that will encourage more solute and solvent particles to interact, and then that will increase the rate of dissolving. Of course, the inverse is true for all of these. Low temperature will decrease the rate of dissolving. Larger, okay, this is the funny one, the larger pieces of solute will decrease the rate of dissolving, and the less you stir or the slower you stir, the less it will dissolve. Okay, hopefully that helps.